All right, let's get right into this because we're looking at a paper today with a really bold claim. And that is the AI models we already have, they're way, way smarter than we think. It kind of suggests we've been looking for intelligence in all the wrong places.
So this brings us to the core question, right? What if, instead of pouring millions into more and more training, the secret was just learning how to listen better, figuring out a smarter way to pull out the answers that are already there, just hiding inside the model?
You know, for years, the big goal in AI has been crystal clear. Make our models better at really complex reasoning. We want them to crack tough math problems, write perfect code, to think like a true expert.
And in that quest, the undisputed champion, the heavyweight title holder, has been a technique called reinforcement learning. We just call it RL. It's really become the go-to method for sharpening a general AI into a specialized genius.
So what exactly is RL? Well, think of it like training a puppy. The model tries to solve a problem. If it gets the answer right, it gets a little treat, a reward. You do this over and over, and this process fine-tunes the model, pushing it to become an expert at that one specific thing, whether that's math, coding, or something else.
But, and there's always a but, right? This drive for perfection has a hidden cost. It turns out that by making the model into such a focused specialist, this champion method has a pretty big flaw hiding in the shadows.
Okay, just look at this comparison. A base model, before all that training, it's super flexible. It can come up with a whole bunch of different creative answers. But after RL, yeah, it's excellent at its one skill, but it loses that flexibility. It gets kind of rigid, hyper-focused. The researchers have a name for this. They call it diversity collapse.
And this quote from the paper just nails the problem. RL is fantastic if you want just one single best answer. But what if you ask it for, say, 5 or 10 different good ideas? Well, its performance actually gets worse. It's like it's learned to put all of its eggs in one single perfect basket.
And this chart, wow, this really shows you that collapse in action. See, when you ask the RL model to generate 16 different answers to a math problem, its accuracy takes a nosedive. It just can't handle that kind of creative demand. But look at this other method, power sampling. Its accuracy stays way, way higher. It's just much more flexible.
So, if our champion has a flaw, what's the plan B? Well, the paper's idea is actually radically simple. Instead of yelling new instructions at the model through training, what if we just listened more carefully to what it's already trying to say?
And this is the whole bet right here. The idea is that the ability to solve these crazy complex problems isn't something we need to force into the model. It's already there, just latent, waiting inside. We just haven't found the right key to unlock it yet.
And that key is called power sampling. Now, the most important part here is that this is a training-free method. It doesn't change the model one bit. It's like a grandmaster in chess. It doesn't just think about the best next move, it looks 5 moves ahead to find the path that leads to a checkmate. Power sampling does the same with words, finding the sequence that leads to the most logical final answer.
This slide really breaks it down. Standard methods are kind of greedy and short-sighted. They just pick the next word that looks good right now. But power sampling is strategic. It's playing the long game. It picks the word that best sets up the entire response for success, avoiding those dead ends down the road.
So, does this simple strategic idea actually pay off? Let's get to the results, because this is where we see the underdog method go head-to-head with the heavyweight champ, reinforcement learning.
All right, first step, we're on RL's home turf. This is the math task it was specifically trained on. The base model alone gets about 50%. The specialized RL model gets a really impressive 78.5%. But then look at power sampling. With 0 task-specific training, it hits nearly 75%. It's almost matching the specialist right out of the gate.
But this is the real plot twist. When you throw them a curveball, a totally new task like a coding challenge, the tables completely turn. The RL model that was trained on math does okay, but power sampling, our flexible, strategic thinker, actually beats it. It's better at adapting to new problems.
And I really can't say this enough. This incredible performance on a brand new problem was achieved with absolutely 0 additional training. None. No expensive compute, no new datasets. It was all just unlocked from the model that was already there. And to really hammer this home, look at this number. For one of the models they tested, power sampling boosted its accuracy on that coding task by a staggering 51.9 percentage points. That is a massive, massive leap in performance.
This table just seals the deal. You can see it clear as day. On tasks outside of their original training and on general helpfulness tests, power sampling just keeps winning. It's not a one-off thing, it's a consistent pattern. This training-free approach is just more robust and adaptable.
So, what does this all mean for the future of AI development? Well, it feels like we're standing at the edge of a new frontier, one that's less about building bigger, more expensive models and more about deeply understanding the incredible ones we already have.
So let's wrap up with the big takeaways. The raw, untapped potential of our base AI models is just immense, way bigger than we realized. We don't always need expensive post-training to get expert-level results. We can unlock it just by being smarter in how we compute the answers. And this new way completely avoids that diversity collapse, giving us a cheaper, more flexible, and honestly, a more powerful way forward.
And that leaves us with one final, and I think pretty mind-blowing question. This research found a hidden genius for logic just by listening in a different way. So it just makes you wonder, what other incredible abilities are lying dormant inside these models, just waiting for us to find the right question to ask?